Hello friends, I am Jairaj Rathod and welcoming you in the solution lecture of assignment 13.3. In this lecture, we are going to learn how we have to simplify the terms before applying the differentiation. How we have to convert the question in the standard form to apply the differentiation. Okay? So let's ready to enjoy the lecture and the questions. Welcome in the first question of assignment 13.3. First of all, let's assume that y is equal to x raised to 4 minus 2 sin x plus 3 cos x. Now let's try to differentiate this equation with respect to x. So it is denoted by dy by dx. Our first term is x raised to 4. In second term, 2 is the constant term. We just have to differentiate the function of x, which is sin x. Plus, in the third term, we have 3 as a constant. So we just focus on the differentiation of cos x. Okay. Now, to differentiate the first term, which is polynomial, we will use the formula of x raised to n. Here, our n is 4. So, the differentiation of x raised to 4 will be 4x raised to 4 minus 1. Okay. Now, let's move to the second term. 2 is constant. We don't have to worry about it. We just have to differentiate the sin x, and the differentiation of sin x is cos x. So let's put 2 cos x. Now in third term, 3 is constant and differentiation of cos x will be minus sin x. Okay, so tada, this is our final answer. 4x cubed minus 2 cos x minus 3 sin x. Let's quickly move to the question number 2. We have y is equal to 3 raised to x plus x cubed plus 3 raised to 3. Here, you have to focus on the position of x. Basically, x is your variable and 3 is your constant. So, the first term is constant raised to variable. In this kind of case, we have to use the formula of a raised to x, where our a is 3, right? So to differentiate the first term, we will use differentiation of a raised to x. Now, if we talk about the second term, which is x cubed, is basically variable raised to constant term, and to differentiate this kind of a function, we have to use x raised to n. Okay. Now, the third term is most funny thing. It is actually constant raised to constant, which is another constant, right? 3 raised to 3 is basically 27. So the differentiation of constant will be 0. So now we are ready to differentiate. So let's differentiate the functions. The differentiation of 3 raised to x will be 3 raised to x log 3 from this formula. So it will be 3 raised to x log 3 plus, in second term, we have x raised to 3. So we can say the value of n is 3. So its differentiation will be 3 x raised to 3 minus 2. So let's put 3 x raised to 3 minus 2. And the third term, which is purely constant term. So the differentiation of purely constant term is 0. So our final answer will be 3 raised to x log 3 plus 3x raised to 2. Tada! Our next question, question number 3. Y is equal to x cubed by 3 minus 2 root x plus phi upon x square. Basically, in second and third term, we don't have the proper form of the differentiation, right? These are the form of the polynomial, and we know that differentiation of x raised to n is n x raised to n minus 1. And to apply this formula, we should convert these terms in standard form. So let me show you how. 1 by 3 is actually constant, x raised to cube will be x raised to cube, minus 2 is another constant, root x is basically written as a x raised to 1 by 2, right? Okay, and if we see phi upon x square, phi is the constant term, and 1 upon x square can be written as x raised to minus 2, right? So now we are ready to differentiate it. Let's differentiate on both the side. So the differentiation of y will be dy by dx, and here 1 by 3 is the constant term. We just have to differentiate x cube, and second term 2 is the constant term. We have to differentiate x raised to 1 by 2, plus phi is the constant term. We will differentiate x raised to minus 2, and to differentiate each term we are going to use only one formula, n x raised to n minus 1. In first term our n is 3, so it will be 3x raised to 3 minus 2, minus 2 will be as it is. In second term we have n is equal to 1 by 2, so it will be 1 by 2 x raised to 1 by 2 minus 1, plus 5 is as it is. Differentiation of x raised to minus 2 will be minus 2 x raised to minus 2 minus 1, right? Now let's simplify our final answer. Here 3 and 3 will be cancelled out, so it will be x raised to 3 minus 2, or we can say x raised to 2. Basically here we will have x raised to 3 minus 1, sorry, minus 2 will cancel out, we will get x raised to minus 1 by 2, and then minus 10 x raised to minus 3, right? So the final answer is x square 1 upon root x minus 10 upon x cube. Ta-da! This is your final and simplest answer. Now let's move to the question number 4. एकदम मस्त क्वेश्चन है, log base. In question number 4 we have y is equal to e raised to x log a plus e raised to a log x plus e raised to a log a. Okay, here we should use the property of log. That's why I get the property of log over here. Okay, now if we talk about the first term, let's move this x to the power using the first property, that if we have log a raised to b, then we can multiply the power with log a, right? Okay, we are not using the formula of differentiation, mind well please. So the first term will be e log a raised to x. Now the same property is used for the second term, so it will be e log x raised to e plus e log a base a, sorry, raised to a, right? Okay, now let's use the third property. If we have e raised to log something, then we can cancel, or we can say they are anti-function of each other, so we can say we will get that term as it is. So e and log are inverse function of each other, so we can neglect e and log simultaneously. So the first term will be a raised to x. Similarly, let's ignore e and log, so the second term will be x raised to a, and in third term we are going to get a raised to a, right? So here we get the simplest form of question. Now we are ready to differentiate it. Let's differentiate. So dy by dx. Now to differentiate the first term, which formula is preferable? You have to find from the formula list, right? So yes, we have for our first formula, differentiation of a raised to x is basically a raised to x log a. Now the second term, which is x raised to a, which is variable raised to constant, so we should use x raised to n, so it will be a x raised to a minus 1, right? Okay, now differentiation of third term, which is a raised to a, will be, you have to think about it, basically a and a both are the constant term, so the whole term is purely constant, so its differentiation is 0. So the final answer is dy by dx is equal to a raised to x log a plus a x raised to a minus 1. Ta-da! Our next question, question number 5. Here we have two different polynomials in multiplication, right? So either we can use the multiplication rule, or we can split the bracket, or we can say multiply the bracket, sorry. Okay, so I prefer to multiply the bracket for the first section. So let's open the bracket. So 2x squared into 3x is going to be 6x cubed, and then 2x squared 2s are 4x squared. Okay, now it's time for 1 3x are 3x, and 1 2s are 2, right? So we get our simplified form. We just have to differentiate it, right? Okay, and you know that our 6 will be as it is. We just have to differentiate x cubed using the differentiation of x raised to n, right? So let's differentiate it directly. It will be like 3x raised to 3 minus 1, or we can say x square, right? Okay, similarly for the second term, 4 is constant, we don't have to worry about it. Differentiation of x square will be 2x plus, in third term we have 3x. 3 is the constant term, we just have to differentiate x. We know that differentiation of x is 1, and the last term is 2, which is purely constant term. We don't have any function of x in multiplication of this constant, right? So the differentiation of purely constant term is 0. So the final answer is 18x squared plus 8x plus 3. Ta-da! Another log based question, and question number 6, our first term is log x base 3. Basically the differentiation of log x base e is 1 by x. We don't have any formula for the differentiation of log x base, rather 3 or 4 or something like that. So we should change the base, and for that we have the formula, the second property of the log, which shown in here. We can split the log b base a as a log b base e upon log a base e. So our first term can be written as log x base e upon log 3 base e. Okay, and the rest of the terms will be as it is, because 3 log x having base e, we don't have to worry about the second term, and the third term is simplest one, 2 tan x, right? Okay, now we are ready to differentiate. Don't worry about the first term, બહુ ગંદો ગંદો દેખાય છે પણ easy છે, ધ્યાન રાખજો. Let's differentiate. Here log 3 base e will be considered as a constant term, so we don't have to worry about the log 3 base e. Okay, we just have to focus on the differentiation of function of x, which is log x, right? So we are going to differentiate only log x. We don't have to write the base e. Okay, don't worry about it. Okay, now in second term, 3 is the constant term. We are going to differentiate only log x, right? And in third term, 2 is constant. We are going to differentiate only 10x. So let's differentiate. Our log 3 base e will be as it is. Differentiation of log x, as we know, is 1 by x, plus 3 is as it is. Differentiation of again log x will be 1 by x, plus 2 is constant term. Differentiation of 10x will be the sec square x, right? We can take 1 by x common, so it will be 1 upon log 3 plus 3 plus 2 sec square x will be the simplest and the final answer. Ta-da! Now let's see question number 7. Another polynomial type. We have two different brackets. First one is x plus 1 by x, and another is root x plus 1 by root x. Okay, we can't differentiate directly. We have to open the bracket, or we should use multiplication rule. Okay, now let's open the bracket. X multiply with root x. Basically, root x is x raised to 1 by 2, and 1 upon root x is x raised to minus 1 by 2. So we have to multiply x raised to 1 into x raised to 1 by 2, or we can say we will get x raised to 1 plus 1 by 2. Okay, now let's multiply x raised to 1 with x raised to minus 1 by 2. So the second term will be x raised to 1 minus 1 by 2 plus, now it's time for 1 by x into x raised to 1 by 2. 1 by x is basically x raised to minus 1, right? So it will be x raised to minus 1 plus 1 by 2 plus, multiply with the second term, x raised to minus 1 minus 1 by 2, right? Okay, so here we have x raised to 3 by 2 plus x raised to minus 1 by 2 plus x raised to minus 1 by 2 again, and finally x raised to minus 3 by 2. Okay, basically here we have plus 1 by 2. Okay, sorry for that. Okay, now we are ready to differentiate. Let's differentiate with respect to x. So to differentiate first term, to differentiate all the term, we are going to use this formula for the in case of polynomial, right? Okay, so in first term we have 3 by 2 as a n, so its differentiation will be 3 by 2 x raised to 3 by 2 minus 1 plus 1 by 2 x raised to 1 by 2 minus 1. In third term we will get minus 1 by 2 x raised to minus 1 by 2 minus 1 and minus 3 by 2 x raised to minus 3 by 2 minus 1. Okay, let's simplify to get our final answer. 3 by 2 is as it is. 3 by 2 minus 1 will be 1 by 2 plus 1 by 2. 1 by 2 minus 1 will be minus 1 by 2. Then minus 1 by 2 will as it is, x raised to minus 3 by 2, and finally minus 3 by 2 as it is, x raised to minus 5 by 2. Ta-da! You can consider this as a final answer. You can simplify if you want. Okay, in next question, question number 8 is like, in the bracket we have root x, or we can say x raised to 1 by 2 plus 1 upon root x, or we can say x raised to minus 1 by 2 the cube. Okay, now before we differentiate it, we have to split this bracket, and if you remember the formula of a cube, a plus b whole cube, it is a cube plus 3a square b plus 3ab square plus b cube, right? So let's use the formula to split the bracket. So our question will be like, x raised to 1 by 2 whole cube plus 3x raised to 1 by 2 the whole square into x raised to minus 1 by 2 plus 3x raised to 1 by 2 x raised to minus 1 by 2 the square plus x raised to minus 1 by 2 whole cube, right? Let's simplify it before we differentiate. X raised to 3 by 2 is our first term. In second term we are going to get 3 x raised to 1 by 2. In third term we are going to get x raised to minus 1 by 2, and in fourth term it will be minus 3 by 2, right? Okay, now we are ready to differentiate. Let's differentiate with respect to x on the both the side. So the differentiation of x raised to 3 by 2 is 3 by 2 x raised to 3 by 2 minus 1 plus 3 as it is. Differentiation of x raised to 1 by 2 is 1 by 2 x raised to 1 by 2 minus 1. Similarly, third term minus 1 by 2 x raised to minus 1 by 2 minus 1 and minus 3 by 2 x raised to minus 3 by 2 minus 1. Okay, let's get the final answer. 3 by 2 x raised to 1 by 2 plus 3 by 2 x raised to minus 1 by 2 minus 3 by 2 x raised to minus 3 by 2 and minus 3 by 2 x raised to minus 5 by 2. Okay, so tada, this is your final answer. Now let's move to the question number 9, in which we have y is equal to 2x square plus 3x plus 4 whole divided by x. Now before we apply the differentiation we have to simplify the term. Always remember to simplify before applying the differentiation, okay, please. Okay, now to simplify these terms we have to give individual denominator. So our first term will be 2x square by x, or we can say 2x. The second term will be 3x by x, or we can say 3, and our last term will be 4 upon x, because third term don't have any x to cut the power, right? So tada, we have our simplified term. Now we are ready to differentiate it, right? Let's differentiate both the side. 2 is the constant term in the multiplication of x, so we just have to differentiate the x, and differentiation of x is 1, right? Okay, now 3 is the purely constant term, so the differentiation of pure constant term is 0, and in third term 4 is the constant term. We have to focus on the differentiation of 1 by x, and the differentiation of 1 by x is minus 1 by x square, right? So tada, 2 minus 4 by x square is the differentiation of y, right? Our next question, question number 10, is quite similar like a 9-1, right? But as I say before, we have to simplify the terms before we apply the differentiation, right? Okay, now to simplify the 10th question we have to simplify the numerator by opening the bracket. So the multiplication of x cube will give us x raised to 4, x cube minus 2 is minus 2x cube, multiplication of 1 with x will give us x, and 1 with minus 2 will give us minus 2, right? Okay, so we successfully simplify the numerator. Now we have to apply individual denominator to more simplification. So this will be x raised to 4 by x square will give us x square, minus x cube by x square will give us x, plus x upon x square will give us 1 upon x, and finally minus 2 upon x square. So yay, we get our simplified terms, individual terms. So we can apply differentiation. Okay, differentiation of x square will be 2x minus 2 is constant. We just have to differentiate this x. So differentiation of x will be 1. Okay, now let's move to the third term. Differentiation of 1 by x is minus 1 by x square. We have in formula list, and minus 2 is constant. We have to differentiate 1 upon x square, or we can say x raised to minus 2, right? And the differentiation of x raised to minus 2 is 2x raised to minus 2 minus 1, or we can say minus 3, right? Okay, so the final answer is 2x minus 2 minus 1 by x square plus 4 upon x cube. Ta-da! Chalo, question number 11. Y is equal to a cos x plus b sin x plus c upon sin x. Okay, now as you know, before applying the differentiation we should give individual denominator to simplify, right? So let's add some extra steps. So first term will be a cos upon sin x plus b sin x upon sin x, and finally c upon sin x. Okay, so our first term, which is cos x upon sin x, will be cot x, plus in second term sin x will cancel out, and the only remaining thing will be b. And in last term, 1 upon sin x is basically cosec x, right? So yes, we get individual terms. Now we can easily differentiate it with respect to x, right? Okay, so in first term, a is the constant term, differentiation of cot x. So where is the differentiation of cot x? Yes, here it is. Differentiation of cot x is minus cosec square x. Now in second term, b is the pure constant term, and as we know, pure constant terms differentiation is 0. And in last term, c is the constant term, and we need differentiation of cosec x. So we should find out from the formula list. Yes, teeny mini differentiation of cosec is minus cosec x into cot x. Ta-da! The final answer is minus a cosec square x minus c cosec x into cot x. Yippee! Our next question, question number 12, purely trigonometric question. We have y is equal to 2 sec x plus 3 cot x minus 4 tan x. Okay, actually it's the simplified form and individual terms, so we can apply differentiation, right? Okay, in first term, 2 is the constant term, so we have to differentiate only sec x, and differentiation of sec x is sec x tan x. Okay, let's move to the second term. 3 is the constant term, we just have to differentiate cot x, and here we have differentiation of cot x minus cosec square x, and the last term is minus 4 is constant, differentiation of tan x is sec square x. Ta-da! एकदम easy question है तो, right? So let's quickly move to the next question. Question number 13. જેટલો વિચિત્ર દેખાય છે એટલો જ ઈઝી છે. a0 x raised to n plus a1 x raised to n minus 1 plus a2 x raised to n minus 2 dot 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 a n minus 1 x plus a n. Okay, individual terms already આપ્યા છે. We just have to differentiate it, right? Okay, dy by dx, a0 is a constant term, we don't have to worry about it. We just have to differentiate x raised to n, so it will be n x raised to n minus 1. In second term, a1 is constant, differentiation of x raised to n minus 1 will be n minus 1, x raised to n minus 1 will be minus 2, plus a2 is as it is, differentiation of x raised to n minus 2 is n minus 2, x raised to n minus 2 minus 1, so it will be minus 3, dot 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 a n minus 1 is constant, differentiation of x will be 1, and finally a n, which is purely constant term, will be 0. Ta-da! This is your answer. હતા ને એકદમ easy peasy. મોટો ક્વેશ્ચન જોઈને ગભરાઈ નહીં જવાનું. Just focus on the differentiation of x. Rest of the terms will be constant. Okay. Question number 14. Y is equal to 1 upon sin x plus 2 raised to x plus 3 plus 4 upon log 3 base x. Here we have three individual terms, but each term don't have any standard form, so we cannot apply direct differentiation, right? So we have to simplify them in the standard form. So let's talk about the first term. First term is the trigonometric term. 1 upon sin x is basically cosec x, right? Okay, now the second term is actually exponential term. We have 2 raised to x, but this plus 3 is not included in the standard form, so we should write like 2 raised to x into 2 raised to 3, right? We can write it like this. Okay, now let's talk about the fourth term, which is logarithmic term. So we are going to need the property of log, and here they are. Okay, 4 is not the problematic part. 4 is the constant, we don't have to worry about it. But we have log 3 base x, so we have to change the base. Log 3 base e upon, or we can say it will go in numerator, that log x base e. Okay, so we are ready to differentiate the terms. So let's differentiate with respect to x. Differentiation of cosec x, we have the differentiation of cosec x minus cosec x cot x, right? Okay, now we have to differentiate the second term. In second term, 2 raised to 3 is the constant. Basically 2 raised to 3 is 8, we don't have to worry about it. We just have to differentiate 2 raised to x, and we have differentiation of 2 raised to x, right? It will be 2 raised to x log 2. So 2 raised to x log 2. Yay. Now let's move to the third term. In third term, 4 as well as log 3 base a is the constant term. We just have to differentiate log x, and we have the differentiation of log x base e, which is 1 by x. So differentiation of log x will be 1 by x. Ta-da! This is the final answer. I know you don't like it, but you don't have to worry about it. Just focus on the differentiation. Okay? Next question, question number 15. Y is equal to x plus 5 into 2x square minus 1 upon x. As we know, before applying differentiation, we have to simplify the terms, right? So let's open the bracket in numerator. So we will get x into 2x square, 2x cube, plus x into minus 1 will be minus x, plus 5 into 2x is going to be 10x square, and 5 into minus 1 is minus 5. Okay, now we have to give individual denominator to get the most simplifying terms. We will get 2x cube upon x, or we can say 2x square, then minus x upon x will be minus 1, plus 10x square upon x will be 10x, and minus 5 upon x. Okay, so here we have the simplest form. Now we can apply differentiation with respect to x. In first term, 2 is the constant term. We have to differentiate x square, which is 2x. Then in second term, which is purely constant term, 1, differentiation of 1 will be 0. And in third term, 10 is the constant, which is in multiplication of x, so we have to differentiate x, which is 1. And in fourth term, minus 5 is constant, we have to differentiate 1 by x, which is minus 1 by x square, right? So the final answer is 4x plus 10 plus 5 by x square. Ta-da! Let's quickly move to the question number 16, which is log 1 upon root x, or we can say x raised to minus 1 by 2, plus 5x raised to a minus 3a raised to x, plus cube root of x square, or we can say x raised to 2 by 3, plus 6 fourth root of x raised to minus 3, or we can say x raised to minus 3 by 4. Okay, now before we apply differentiation, we have to simplify this first term, because we have log x raised to minus 1 by 2. So using the first property shown in here, it will be minus 1 by 2 log x. Rest of the terms will be as it is. So we are ready to apply the differentiation, right? Let's differentiate one by one with respect to x. Here in first term, minus 1 by 2 is constant. We just have to differentiate log x, and we know that differentiation of log x is 1 by x. Okay, let's move to the second term, 5x raised to a. Basically it's the differentiation of x raised to n. We just have a instead of n, so it will be a x raised to a minus 1 is the differentiation of x raised to a, right? Okay, and for third term, 3 is the constant. We just need differentiation of a raised to x, which is a raised to x log a. Okay, now let's move to the fourth term, which is x raised to 2 by 3. Basically it's just differentiation of x raised to n. We have 2 by 3 instead of n, so it will be 2 by 3 x raised to 2 by 3 minus 1. And for the last term, we have 6x raised to minus 3 by 4, or we can say x raised to n. We just have minus 3 by 4 instead of n, right? So minus 3 by 4, x raised to minus 3 by 4 minus 1. Yay! We apply the differentiation. Now we just have to simplify it. Minus 1 by 2x plus 5a x raised to a minus 1 minus 3a raised to x log a plus 2 by 3 x raised to 2 by 3 minus 1 is basically minus 1 by 3, and finally 6 into minus 3 by 4 will become minus 9 by 2 x raised to minus 7 by 4. Ta-da! This is the final simplest answer. Okay, now let's go to the question number 17, which is y is equal to cos x plus a. We just have one trigonometric term, but as you can see we don't have the differentiation of cos x, so we should simplify, or we can say open this bracket. But to open the bracket we have to use the formula of trigonometric term. We know that cos alpha plus beta is cos alpha cos beta plus minus sin alpha sin beta, right? So let's simplify this. We have x instead of alpha and a instead of beta, so it will be cos x cos a minus sin x sin a, right? Okay, now we have individual terms, so let's try to differentiate it. You have to mind well that cos a is the constant term, because a is constant, so its cos will also constant, so we don't have to differentiate the cos a. We just have to focus on the differentiation of cos x, and yes, we know that differentiation of cos x is minus sin x, right? Okay, now in the second term, as you can see, sin a is constant, so we don't have to worry about the sin a. We just have to differentiate sin x, and yes, we also know that differentiation of sin x is cos x, right? So the final answer is minus common cos a sin x plus sin a cos x, right? Or we can say minus sin x plus a. Ta-da! This is your final answer. Welcome in the last question, question number 18 of the first section. We have cos x minus 2 upon sin x, and as you know, we have to simplify the numerator before applying differentiation, and to simplify the numerator we should use cos alpha minus beta's formula, which is cos alpha cos beta plus sin alpha sin beta, right? Okay, so let's use alpha as a x and beta as a 2, so our numerator become cos x cos 2 plus sin x sin 2, and we already have sin x in denominator, right? Okay, now let's apply individual denominator. So we are going to get cos x upon sin x into cos 2 in first term, and sin x upon sin x into sin 2, right? Here sin x will cancel out, and in first term cos x upon sin x is basically cot x. We don't have to worry about the cos 2 because it's a constant term, and in second term we have sin 2. Okay, so yes, we get our simplest y. Now we can differentiate it with respect to x. We don't have to worry about cos 2 because it's in the multiplication of cot x, and the differentiation of cot x we know minus cos x square x plus sin 2, which is purely constant term, and the purely constant terms differentiation is 0. So tada, our final answer is cos 2 into cos x square x. Yippee!